This is lesson 6.7, graphing linear inequalities in two variables. You should be on page 405. A linear inequality in two variables like x minus 3y is less than 6 is the result of replacing the equal sign in a linear equation with an inequality. So that sounds kind of confusing. Another way of saying it is if you look at this, do you notice if there was an equal here, this would be standard form, a standard form equation. If you take a standard form equation or a slope-intercept form equation and you replace those equal signs with inequalities, you now have a linear inequality in two variables. Remember, slope-intercept form looks like this, y equals mx plus b. And standard form looks like this, ax plus by equals c. So do you notice right now that this inequality is in standard form? We have ax plus or minus by, they have less than c. It's a standard form inequality, basically. Now, a solution of an inequality in two variables is an ordered pair that produces a true statement when the values x and y are substituted into the inequality. Let's do an example of that. Which ordered pair is not a solution of this inequality? Well, let's try 0, 0. If I plug in 0 for x and 0 for y, I would get 0 minus 3 times 0 less than equals 6. This would be 0 minus 0 less than equals 6, 0 less than equals 6. That's true. So A is a solution. I want an ordered pair that's not, so it can't be A. Let's try B. Remember, x is 6, y is negative 1, so I'm going to put a 6 in for x and a negative 1 in for y. Well, this would be 6. Now, negative 3 times negative 1, we got to multiply as positive 3. This says 6 plus 3 is less than equals 6. Is that true? No, this is 9 less than, that's false. Okay, so B would be the correct answer because B, when I plug it in for x and y, it's not a true statement. All right. Ordered pairs which make the inequality true are called a solution. That's not a solution. Let's have you try. Look at the bottom of page 405, pause the video and try. Is 1, 2, and 3, are these three questions? Check and see if these ordered pairs are a solution. Pause the video. Okay, you're back. So you should have found out that when you plug in 0, 0 here, you're going to get 0 less than 8. That's true. So 0, 0 is a solution. When you plug in 0, 4, you should be getting 8 less than 8, which is not true. So that's not a solution. When you plug in 3 and 5, you ought to be getting 7 less than 8, which is true. That is a solution. Now, graphing an inequality. In a coordinate plane, the graph of an inequality in two variables is the set of points that represents all solutions of the inequality. You're probably thinking, geez, we got a graph again. Now remember, inequalities have infinitely many solutions. So that means if I ask you to go home and write down every ordered pair that makes the inequality true, you'd never get the problem done. Graphing is actually the shortcut. So don't have a bad attitude about it. It only takes you a half minute to graph it. It would take you forever to write all the solutions or make a table of them. Okay? So we're going to graph inequalities. They show me all the solutions. Now, when you graph inequalities, you will have a boundary line which divides the coordinate plane into two half planes. You're drawing a line on your paper that's going to split your graph in two parts. Those are called half planes, and that line is called a boundary line. One half plane contains the points that represent the solutions of the inequality. So this statement in yellow saying one side of the graph would be the solutions, the other side of the graph wouldn't be. So how do we get this graph made? Graphing a two-variable inequality. So the first thing you do is you graph the boundary line. Now, we're going to do an example together here in a minute, but you are supposed to use a dashed line if the inequality is a less than or greater than inequality. But you use a solid line if there's equals in it. If you have less than equal or greater than equal, then you use a solid line. So it's a dashed line if there's no equal in it, but it's a solid line if there is an equal in it. From there, you're going to test the point not on your boundary line to see which side of the boundary line you should shade. You are then going to shade the half plane containing the point if the ordered pair is a solution. If it's not a solution, you'd shade the other half plane. So if you're sitting there, and I would pause the video and write these things down, but if you're like, that isn't quite making sense, we're going to do a problem together and look at it, okay, and actually work through these steps. All right, let's look at this one in the book so it makes sense, and then we'll do a one together. Graph the inequality 4 greater than 4x minus 3. So first of all, what I want you to do is I want you to think about, this is slope-intercept form. You notice here in the book, pretend that it says 4 equals x minus 3 first. Now, this is in slope-intercept form. The slope is 4, and the y-intercept you can see here is negative 3. So look what they do on graph paper. They went down 1, 2, 3. There's your y-intercept. And here's your slope of 4. 1, 2, 3, 4 over 1. And you can see that's how they get the line. Now, what kind of line should I draw? Should I draw a bold or a dashed line? Well, let's look at our inequality. Do you notice how the inequality does not have an equal in it? That means you use a dashed line. So that means any points on this line are not part of the solution set. It's the fence, but the points on the fence won't make this a true statement. Okay, now we got to figure out what side to shade. You got to test the point. So let's try testing a point. Oops. Let's test the point here. The easiest thing to test is 0, 0. It's the easiest point to plug in. Do you notice here how 0, 0 is on the left side of the boundary line? Let's plug it in and try it. If I put a 0 in here, and then I put a 0 in for x, I get 0 is greater than 4 times 0, which is 0, minus 3, and that's 0 greater than negative 3. Well, that's true. That means this point is on the side of the fence where the points are solutions. So what you do is you take your pencil and you shade in the left side of this boundary line, which you see they kind of did that with the side of their pencil. Any points in this half plane make this statement true. Okay? Let's try one of our own down here. Graph the inequality x plus 3y greater than equal negative 1. Now, do you notice that's in standard form? I want to get this in slope-intercept form. So let's quickly take away x, which gives us 3y on the left, and I should have put greater than equal. There we go. Greater than equal negative 1x minus 1. And then I'll divide everything by 3. And there's my inequality in slope-intercept form. So let's go ahead and let's graph that now. Okay, do you notice my y-intercept is negative 1/3, and my slope is also negative 1/3. Maybe I should highlight those. There's my slope, negative 1/3. You can see I highlighted that in yellow. And here's my y-intercept, negative 1/3. I'm highlighting that in pink. Okay, so let's start graphing. My y-intercept's negative 1/3, so I put a point here. I approximated down 1/3. And then from there, can you see how I'm going down 1 over 3? And then from here, down 1 over 3. And then from here, down 1 over 3. There's my line. You can see it. Now, should I use a bold line or a dotted line? Well, look carefully. Let me highlight my inequality. Let's look at it. Do you notice how the inequality has an equal in it? You should use then a bold line. Okay, I got to test a point to see which side, one of these sides have the solutions, the other side has the non-solutions, or the points that don't work. So we got to test a point. You notice how 0, 0 is above my boundary line. 0, 0 is always the easiest point to check on. It's the least mass. So let's try 0, 0, plug it in. If I put a 0 in here, and I put a 0 in here and here, I would get 0 greater than equal, negative 1/3 times 0 is 0, minus a third, which gets me 0 greater than equal negative third. That's true. That's a true statement. So that means 0, 0 is part of the solution side. So I should be taking the side of my pencil. It's kind of hard to do with this marker here. But I should be shading everything up here. Any points above my boundary line, any of these points would be solutions. And you can see there's an infinite amount of correct answers up here. So that's why we're doing the graphing. It's easier than actually naming them all. Now when you have a linear inequality in one variable, the steps for graphing these that we just did for two variable can be used to graph the linear inequality in one variable. Okay? This is a great review of one variable graphing. The boundary line for an inequality in one variable is either vertical or horizontal. And remember, the vertical equations are like the remember, x equals 3. That would be go 3 units to the right on your graph paper and draw a vertical line 3 units to the right of the origin. Or here, horizontal would be the y equals equation. And then you'd use a test point and decide what side to shade. So if an inequality only has the variable x, you substitute the x coordinate of the test point in the inequality. If the inequality only has the variable y, then you'd substitute the y coordinate. Here would be a good example. Graph the inequality y greater than equal negative 3. Okay, so you might remember from earlier in the year, y equals negative 3 would be that horizontal line across my paper 3 units below the origin. Do you notice how there's equals in this problem? That's why they used a bold line. Okay, now I got to figure out which side to shade. So the book used the point 2, 0 to test. I'm just going to use the point 0, 0 to test. Okay, now there's no place to plug in an x in this inequality, so I just disregard that point. But y is 0. Let's try plugging that in and see if it's a true statement. Is 0 greater than or equal negative 3? And I hope you're sitting there thinking, yes, 0 is bigger than negative 3. So 0, 0 is on the solution side of this boundary line, so I would shade everything above the boundary line. Any of these points up here are solutions, or any point on the line is a solution. Okay? All right, keep going. Here's one more. Graph the inequality x less than negative 1. So the first thing I do is I go to x equals negative 1, and I'm going to draw a line. And you notice it's one left vertical line. There's no equal in the problem, so I used a dashed line. Okay? I always like testing the point 0, 0. So let me try testing 0, 0. It's right here. Okay, so x is 0, y is 0. Now there's no place to plug in y in this, so I'm just going to disregard that, but I'll put a 0 in here for x. 0 less than negative 1, is that true? Is 0 smaller than negative 1? And I hope you're saying, Mr. Lemansky, that's not true, it's false. Okay, so 0, 0 is on the non-solution side of the fence. That means I have to shade this side of the fence, and that's what they did. Any of these points over here would make this a true statement. Okay? Wrapping the video up, you'll have some word problems that would be written into two variable standard form equations that we can graph and find the solution to. So in this problem, you have 2 summer jobs at a youth center. You earn $8 an hour teaching basketball and $10 an hour teaching swimming. We're going to let x represent the amount of time you teach basketball, and y is the amount of time you teach swimming. You want to earn at least, so at least means I want to earn 200 or more a week. So let's look at the equation they write. $8 an hour for each hour of teaching basketball plus $10 an hour times each hour of teaching swimming has to be more than or equal to 200. Okay, there's my inequality in standard form. Now I want to graph it. So remember, the hours of basketball are my x's, which they labeled, and my hours of swimming are my y's, which they labeled. Okay, so now I got to graph it. So here's the first thing. I would use intercepts. Okay, that's a good review of some chapter 4 material. Okay, so if x is 0, if I put a 0 in for x, which would cancel this out, 10 times what is 200? Well, 10 times 20. So when x is 0, y would be 20. So you notice they plotted that, 0, 20 right here. Okay, now, what if y is 0? Let's put a 0 in for y, which would make this nothing. 8 times what equals 200? Well, 8 times 25 is 200. So there's this is my y-intercept here, and here's my x-intercept. So let's go graph 25, 0, 10, 25, 0. Now, do I use a bold or a dotted line? Well, I have an equal in the problem, so you notice they have a bold line. Now, you notice they did not go into fourth or second quadrant because we can't have negative solutions. Okay, I got to test a point. I'll pick 0, 0. If I worked 0 hours of basketball teaching and 0 hours of swimming teaching, would I make at least $200? And I hope you all understand the answer is no, I wouldn't make 200. So this is the wrong side of the fence. It's the other side of the fence that would give me the solution. So any ordered pair on this line or up here would make this statement true. And then they always ask at the end, or a lot of these questions, name 3 points on my graph that would be a solution to the problem. Give 3 total combinations that would allow you to meet your goal. Well, any points up here would do that. Like, for example, let me highlight some in blue, and then I'm going to stop the video. Like, if I did 20 hours of basketball and 10 hours of swimming, that point is definitely in the shaded area. That would be a solution. So I could say 2010 would allow me to at least make $200. 20 hours basketball, 10 swimming. Or what about if I did 30-30? Well, that's certainly going to give me at least $200. Or what if I just don't like basketball? I do 0 basketball and 25 hours of swimming teaching. You notice how that point would also be a solution. So I could write those 3 points down, and that would answer the question listed here. Give me 3 possible combinations that would allow me to meet the goal. I'm going to pause the video there. If you have questions, make sure you ask in class.